Hi, I'm Zara, and today I'll be talking about ethanol and its reduction of air pollution, as well as how it's a fuel derived from biomass sources. So, in this presentation, I'll be talking about what is ethanol fuel, how it's developed, and the impacts, as well as further steps in ethanol production. So, starting off, what is ethanol fuel? This is a renewable resource derived from the natural fermentation of sugars. It is primarily cultivated from corn, but I'll get into that in later slides. Additionally, it has a higher octane number than regular gasoline, and this provides stability and durability to the vehicle, which is providing gas too. So, moving on to the development of ethanol, dry corn milling is the process of production that ethanol will go through. So, this is used with five steps: grinding, liquefaction, saccharification, fermentation, as well as distillation. So, for the first step in the process, it uses grinding, which uses the hammer mill, this machine right here. And the hammer mill is used to break outer coatings of corn kernels, increasing surface area of the starch. So the corn kernels will go through this opening over here, which will then they'll go down and then they'll be grinded up and dispensed out here. And once the corn is broken down, it's mixed with heated water and produces a mash. Liquefaction and cooking is the next step, which water will interact with starch granules and this thickens the mixture of the starch. This uses partial processes of hydrolysis. This breaks down larger starch chains into smaller ones. Liquefaction has more steps to it, but I'll get into that more in the next slide. The third step will be saccharification, which is the addition of glucoamylase, providing further hydrolysis, which will fully convert starches to glucose ready for ethanol production. So after these two processes of liquefaction and saccharification, the starches will be broken down into more simple sugars such as glucose. So the fourth step, fermentation, yeast is added into the batch, which will then it'll be incubated in 30 to 32 degrees Celsius temperature for 2 to 3 days. And in doing so, 90 to 95% of glucose will be converted to ethanol. And the final step of distillation. So this uses heat to keep liquids such as water flowing downward and vapors such as ethanol flowing upwards, which separates the two. And it also uses dehydration, which absorbs water, excluding the ethanol. Looking more into the liquefaction process, and to do this, you'd have to adjust the pH of the starch, which means you'd have to keep it at 5.9 to 6.2. And to do that, ammonia and sulfuric acid is added to maintain the pH. After that pH is maintained, this is when you add initial A amylase, which improves mash flowability before it's heated. After the addition of the enzyme, it's then going to be incubated in 85 to 95 degrees Celsius. And this process is very important because yeast is only able to ferment in simple sugars like glucose, not starch, like I said before. So then those glucose will be fermented into gas. The development status of ethanol. This is a mature first generation production. Its commercial production is well established, producing ethanol from food crops. As I said before, it's produced from corn, and its most fuel production is located in the Midwest region, as we can see in this chart on the right. And most research and development now is focused on using non-food sources such as agricultural waste and algae. And this is mainly to avoid competition with food production. More efforts are also used to improve the efficiency, so developing new yeasts and enzymes. That in turn will lower the production costs because it's going to take less time to produce these products. Moving on to the impacts, the carbon footprint studies shown that the use of corn ethanol has reduced carbon emissions as well as significantly decreasing greenhouse gases. From 2005 to 2019, carbon intensity reduced 23%. Looking at this chart on the right, we can see that ethanol compared to gasoline, there is a very big difference between the two in how much carbon emissions they let out. Its economic impact, ethanol production has resulted in greater job prosperity and as a result, higher income in farmers producing corn for production. Ethanol generated 53 billion to the nation's GDP, which is the gross domestic product, and estimated 26 cents per gallon, which is 40% lower than the national average. And finally, the further steps in ethanol production. Efforts to communicate the use of ethanol can include campaigns of public awareness from government-led campaigns to inform the public about greener fuel options. And some methods of this would be digital content advertising campaigns, as well as the Department of Energy. There's a very good resource which provides mass amounts of information usage, cost, and production of ethanol fuel. And it's important to note that COVID-19, they caused major cuts in ethanol production due to the reduction of gasoline consumption because as we know, in COVID, not many people were leaving, not many people were using their cars, so that means they weren't using as much gas. To avoid cuts for ethanol production in the future, we could diversify products from ethanol, not just limiting them to fuel markets, producing products from ethanol like sterilizers, sanitizers, things like that. So as a result, doing that could lead to less cuts in the production because there's more use for ethanol. And moving forward, also things you can do without considering budget as an issue, we can transform ethanol plants into zero carbon refinery, which would be converting plants to 100% renewable energy, as well as adding carbon capture and storage, which will capture nearly all fermented carbon dioxide. Lastly, accelerating next generation biofuels, which would drastically better for the environment. Using cellulosic sources of ethanol, which is non-food biomass, would produce ethanol with reduced levels of greenhouse gases. And that's all I have to say about ethanol production. Thank you for listening.